Hey guys, welcome to my new series called Sensor Series. In this string of episodes, we'll be going over the basic sensors in LEGO Mindstorms and a little bit of the programming behind how to use them. In this episode, we will be exploring the ultrasonic sensor, a very useful tool for determining distances. Let's make a simple program to illustrate how it works. First, let's start with this drivetrain block. Take the motors, two motors, attach them to the correct ports. It can be B and C, or you can change them around, doesn't matter. And then let's set it to run indefinitely. So if we were to run this on a robot, it would just keep going forever. But if we put a wait block in front of it, this drive forward will check to see if this wait block is still true. So right now it's set to time, seconds 1. So this program will drive forward at 75% power on each motor for 1 second, and then it will stop. Let's tell it to stop right here. Off. It will stop. But we don't have to use time. We can do something else. Like let's say we wanted to use the ultrasonic sensor. Now, for this episode and for FLL in general, we're only going to be using distance. So let's use distance in inches, because that's a metric we're all familiar with. Let's decode this block a little bit. First, let's go over the compare. This block, this wait block, is capable of comparing several different methods. Equals, not equal to, greater than or equal to, less than, and less than or equal to. Let's focus on greater than right now. This is the threshold right here, the threshold value. So this one measures how far something is away in inches, yes. So this is 1% of the threshold. It doesn't actually compare a direct metric. We know how far it can go. It has a range of about 255 centimeters. And if you can compare that to inches, we know that at 100%, that's 255 centimeters. At 1%, that's a fraction of it. It's 2.5 centimeters. We're going to do it in inches. All you have to do to convert between inches and centimeters is divide the inches by 2.54. But that's not important. Anyway, so let's set this threshold to 50, which will be about 27 or so centimeters. 50. So now what this program will do is it will check it will keep running forward at 75% power until you get within this threshold value, this 50% of the maximum, a medium distance away from the ultrasonic sensor. And when I say it could be really anything. It could be a wall. It could be another game piece. It could be an actual wall. It doesn't matter. As long as it hits some solid surface that can reflect the sound waves backwards. And then once it detects it, it will continue running the program and it will stop. So let's make a little more complicated of a mechanism right here. The motion turn. So let's say we wanted it to actually go forward, let's say 10 rotations. Then we want it to turn at 60 degrees, 66 degrees, sure, at 75% power until it gets within a threshold of 20. Now again, remember the threshold doesn't actually correspond to a concrete number. It's just a percentage of the total distance it can see. This will take a little bit of gerrymandering. And then it will turn at 60 degrees to the right until we want it to stop. So let's go over it. 10 degrees forward, turn 66 degrees to the right. Notice it goes to the right. If we were to make this negative 66, it would go to the left, but it will go to the right. At 75% power until we get within a threshold value of 20. Then it will stop. So this block is not just good for comparison, it can also read out values. So let's say you wanted to know how far something is away from it for sensing purposes or what have you. You can do this measuring part. Now, the measure beacon is not actually that important. Whoops, I grabbed the wrong thing. This is the ultrasonic sensor. We can have it do a measurement in centimeters, measurement in inches. For this, we're going to be doing measurement in inches. And then it gives this little output here. If you're unfamiliar with what an output is, I will cover more of that in my basic and advanced programming class. But to keep it simple, The output you can give to some sort of variable you can assign, and if you don't know what a variable is, it's just a way of holding a number. So if you wanted to hold the number right there, you could plug that in, and then this variable, we could call it foo, would be holding the value of however far the wall is away from the robot. Let's look at another example of how to use this ultrasonic sensor. Let's drag a switch function here. And again, if you're unfamiliar with what these are, check out my basic and advanced programming courses. This switch, you can use the ultrasonic sensor, compare distance in inches or centimeters to a certain threshold, and then it will check. So now let's say you wanted to play a sound within, when something gets within 50 of the threshold, a very loud sound. So now it will check to see if something is within a threshold of 50, and if it is, if it's less than 50, then it will, and if it's greater than 50, it won't play this loud, annoying sound. That's it for the ultrasonic sensor right now. Some of those concepts may have been a little confusing if you're unfamiliar with the more advanced programming. As I said, check out my beginning and advanced programming classes. But until then, keep watching and keep creating.